Okay, so for this problem, we set up what we did is this is a follow-up from something that was posted in the discussion forum. We know that there's a 1 in 300 chance that somebody's infected with a virus. So I wrote, so and event A was that the person gets infected or is infected. So I wrote A, the chance of it being a positive infection is 1 out of 300, and negative would be 299 out of 300. And then event B is that the test accurately detects, or the test positive. So for event B, it's an 85% success rate for the test if the person's actually infected. So for this branch, I wrote 0.85, and for being, yes, the test did pick up the antibodies, or 0.15, the test did not. So it's basically that's a false negative. The person's actually infected, but the test didn't pick it up. And then for the other result, it says there's a 5% chance of somebody having a false positive or picking up the test saying, yes, the antibodies are present when actually they are not. So that's a, a false positive. And of course, the complement of that is 1 minus 0.05 and so 0.95. Is that it would accurately pick up and say that there's no antibodies present and the person's not infected. So then to get the probabilities, what I suggested was multiplying the legs to get these probabilities. So if you do 1 divided by 300 times 0.85, you get an answer. And that's, yes, the test accurately detected the presence of the antibodies in a positive person. And this one be the false negative, the result that detected antibodies, it failed to detect the antibodies when the person was actually infected. And this is saying, yes, the person's infected when actually they're not. And this is, the test was accurate. It said, no, the antibodies are not present, and they really weren't. So then find the probability that a person has the virus given that they've tested positive. Okay, so so what I did is that they tested positive given that they actually were positive. So that's these two results where the test said, yes, this is a positive test result, and this was a positive test result, but the person was actually negative down here. So we want the probability, so if you think about that conditional probability, so they're going to find the probability that they tested positive given that they tested positive. Well, what we want to do is think about that formula, which says the probability of actually positive and they tested positive. I'm going to run out of room writing, so you're going to have to just pay attention to the voice, I guess. I'm sorry. So that's the and over the probability that they tested positive. And since we're looking for this probability, this conditional probability, we gotta find these numbers. So, and the tested positive and actually were positive is this result right here. So I don't have those numbers right handy, but that probability is 0.85 times 1 over 300, right? Whatever that number is. So that's the and then what's the probability that somebody tested positive? Well, that's the sum of these two probabilities. So it's going to be the sum of whatever 0.85 times 1 over 300 is, plus the probability of that they're tested positive, they're actually negative. So that was what? 299 over 300 times 0.05. I get my pen working again. Well, we'll do it this way. Times 0.05. Okay, and that would be that first answer. And then what's the probability that somebody does not have the virus given that they tested negative? So we're looking for this number. So this is this value down here will be they tested negative and they are negative. So it'll just be this number divided by the sum of these two numbers. And that should be the right answer. Give it a whirl. There's probably a exercise just like this in the textbook. I'll post that in the forum. Okay, so hopefully that helps clear it up for you.